This is Sharika UR14CS122. Today we are going to see Unix third experiment, looping and control structures in shell programming. So our first program is to write a shell script to print Fibonacci series. So here's the code. So first we enter the range, we read the range from the user, and then we've initialized I and j as 1, and then we display those numbers, and then we have a for loop here so that we can go through the loop, and we can add the two consecutive numbers, that is 0 1, and then 0 plus 1 gets added, we get 1, and then the pointer changes. Then we store j as I and a as j, and we continue the loop, and hence we get the series. So let's see the output for this code. Here we go. So 0 plus 1 we get 1, 2 plus 1 plus 1 2, then 1 plus 2 3, so on. So let's see the next program. Next program is to write a shell script to find the sum of the following series, that is 1 squared plus 3 squared plus 5 squared, that is the sum of the prime numbers, odd numbers, sorry, the square of the odd numbers. So here we go. So first we enter the range, first we get the range from the user, and then here inside the for loop we increment the number by 2, so that from 1 it goes to 3 and only the odd numbers are taken, and then we square it. For that we use and square it, and we store into variable called su, and then we add the sum. So each time the for loop it goes through the loop, it gets added, and hence we get the result. So let us see the output. Here we go. This is our range. So here this is the sum of 1 squared plus 2 squared plus 1 squared plus 3 squared plus 5 squared. So this is our result. Let's see the next program. The next program is to write a shell script to check whether the given number is an Armstrong number or not. Armstrong number is that, suppose we take a 3-digit number 153. So 1 cube plus 5 cube plus 3 cube should be equal to 153. So that is Armstrong number. So first we enter the number, and then we store the number into a variable called old, and then we use a for loop, and inside that, this is the logic for an Armstrong number. We first modulo the number by 10 so that we get the first two digits, and then we cube it, and then we add it, and then so on. So this goes on, and then if the number we get here is equal to the number that we've entered, then it's an Armstrong number, else it's not. And let's see the output. So 153 is an Armstrong number. So let us see the next program. Next program is to check if the given number is in palindrome or not. Palindrome is the reverse of that, the reverse of the number. So here first we get the input from the user, and then like the previous program we store the number in a variable called ORI, and then we use a while loop here. And then this is the logic. We first modulo it by 10, and then 10 plus reverse rev into 10, and then divided by 10. So this goes through the loop, and then finally the number what we get in REV, if it is equal to the number that we stored in ORI, then it is a palindrome, else it's not. So let's take a 1 2 2 1. So this number is a palindrome. Let's see a next program. Our next program is to print the prime numbers between the given ranges. So here we get the range from the user, and then here we use two for loops. So inside the first we go into the for loop and set the flag as 0, and then we use the next for loop to compare we use the next for loop and we modulo the number the I with j. So I stands like the first number of I is moduloed with all other, like that is the first number is moduloed with all other numbers, and then if the modulo value equal to 0, then flag is set as 1, or else it still remains as 0. So that procedure goes on, then I gets incremented, and then all the other numbers are moduloed, and that procedure is carried on. And then finally, if the flag value equal to 0, then that particular number is a prime number, hence it displays those numbers as prime numbers. So let us see the output. Let's give range 10. See, these are the list of our prime numbers. Then our next program is to write a shell script to sort elements of an array in ascending and descending order. So here in this particular code, we've used bubble sort. Okay, so here first we get the numbers in the array, we get the numbers from the user, and then just a second. Okay, so here first this is a logic for descending order sorting, and this is for ascending order sorting. So in descending order we've used the switch case here. So in case 1, first we get the we've used two for loops here. So what happens is, here it checks if the first number is less than the second number. If the first number is less than the second number, it gets swapped. So first number is stored in T, and then in I the second number comes in, that is j value is put in I, and then j gets the value of T. Like what is there in T? The value of I. So it basically gets swapped. So each time then I gets incremented. Then the next number, I remains the same, and then the other number, all the other numbers in the array are checked. So the first number with the second number, first number with the third number, first number with the fourth number. So how many ever numbers are there, and then I gets incremented. Then the second number is checked with all other numbers, and then if it is less than the particular number, it gets swapped. Hence the array is sorted in descending order. So it is basically same for ascending order, just that if the number is greater, then it gets swapped. So that we can arrange the array in ascending order. So that's the only difference. So this is how we sort the numbers in ascending and descending order. Let's see the output. So let me give the range my array value is 6. The total values to an array is 6. So let me go for descending order sorting. Here we go. So this is this particular array has been sorted in descending order using bubble sort. Hence this is our experiment 3.